Metals, non-metals, metalloids, physical properties. The first one. What are the physical properties of metal? Okay, shiny or lustrous, good conductors of heat, and electricity. So those are the properties of the physical properties of metals. Now the second one, do metals typically gain or lose electrons? You can say metals lose electrons to form positive ions, which we call as cations. Then the next one, what does ductile or ductile mean? So we say ductile. This one means a material can be stretched or pulled into a wire without breaking. Then there's no more space. You can go to the next page. Okay, number 4. What does malleable mean? So malleable, malleable means a material can be hammered or rolled into thin sheets without breaking. Then number 5, why are metals good conductors? You can say metals conduct well because, so metals conduct well because they have free moving or delocalized electrons that carry electric charge and heat through the material. What are the physical properties of non-metals? The physical properties of non-metals. They are typically dull, not shiny, then poor conductors of heat and electricity, then brittle when solid. What else? Okay, many are gases at room temperature. Then they have lower melting and boiling points. Than metals. Now you can go to the next page. Alright, okay. Why don't non-metals conduct electricity well? You can say non-metals They don't conduct electricity well because they don't have free electrons. Like metals do. So the electric charge cannot move through them easily. Then for number 8, do nonmetals gain or lose electrons? So nonmetals typically gain electrons to form negative ions, which we call as anions. Then for number 9, why are nonmetals typically brittle? Let's see, nonmetals are brittle because so nonmetals are brittle because their atoms are held together by strong directional bonds that break easily when stress is applied. Then for number 10, what are metalloids? So metalloids are elements that have properties of both metals and nonmetals. Metals and non-metals. So examples of metalloids are silicon, boron, arsenic, and germanium. Yeah. Okay. Why are metalloids useful as semiconductors? So metalloids, especially silicon and germanium are useful as semiconductors because they conduct electricity. Okay. Metalloids, especially silicon and germanium, are useful as semiconductors because they conduct electricity. Only under certain conditions. So they don't conduct electricity all the time. Then they can be controlled by adding small amounts of other elements. Then what else? They have electrical properties. Between metals and non-metals. So that's why this makes them perfect for electronics like computer chips. Then for number 12, periodic table. Number 12. Why are group 1 alkali metals highly reactive? So group 1, alkali metals are highly reactive because they have one valence electron. That is very easy to lose. Then for number 13, how many valence electrons do alkali metals have? So alkali metals have one valence electron. How many valence electrons do alkaline earth metals have? So alkaline earth metals have, this is group 2, so 2 valence electrons. Then for number 15, why are alkaline earth metals less reactive than alkali metals? Okay, alkaline earth metals are less reactive than alkali metals because they have 2 electrons. And because they must lose 2 electrons instead of 1. And this takes more energy. And number 16, what are the common properties of transition metals? So common properties of transition metals. Good conductors. Then they are hard and strong. Then they have high melting points. Then they form colored compounds, so they often form colored compounds. Then they can form multiple oxidation states. Then number 17. Number 17. Why are transition metals good for wiring and building materials? Transition metals. Because they are strong. Because they are strong, malleable, good conductors, and resistant to corrosion. This is for transition metals, number 17. The question is, why are transition metals good for wiring and building materials? So those are the reasons why. They are strong, malleable, good conductors. Then for number 18, why are halogens or group 7 very reactive? So halogens in group 7 are very reactive because they have 7 valence electrons and want one more electron, one more to fill their outer shell. They have 7 valence electrons, so to complete the octet, if you draw a Lewis structure, you need one more there to complete it to 8 electrons. Then for number 19, how many valence electrons do halogens have? Okay, they have 7. So halogens have 7 valence electrons. Then 20. Why are noble gases unreactive? And noble gases are unreactive because they have full valence shells, 8 electrons. They have 8 electrons except for helium. That has 2 electrons, and they are stable. So they don't react. What makes noble gases different from halogens? Noble gases have full valence shells, which make them unreactive, while halogens need 1 electron which makes them highly reactive. Then 22. What are diatomic elements? So diatomic are elements that naturally exist as 2 atom molecules. So the diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You can use the mnemonic, have no fear of ice cold beer. Have no fear of ice cold beer. Yeah, we do like this, HNFOICB. So have no fear of ice cold beer. And then 23. Yeah, it will be easier to memorize. Then 23. Why do some elements naturally exist as diatomic molecules? They naturally exist as sharing electrons in a pair. So they naturally exist as diatomic molecules because these atoms are unstable atoms and become stable by sharing electrons in pair. Then 24. What is atomic radius? So atomic radius, this is the size of an atom. The size of an atom, or the distance from the nucleus to the outermost electron shell. And for number 25, why does atomic radius increase going down a group? Going down a group, atomic radius increases because atoms gain more electron shells. That's why it's increasing in size. Okay, going down a group, atomic radius increases because atoms gain more electron shells. Okay, 26. Why does atomic radius decrease going left to right across a period? Atomic radius. Yeah, atomic radius decrease going left to right across a period because the number of protons increases, pulling electrons in tighter, shrinking the atom. Then number 27. Okay. What is effective nuclear charge? So E and C. So E and C is the pull of the nucleus on the valence electrons after accounting for shielding. Then 28. How does shielding affect atomic size? So the more shielding, the weaker the pull on outer electrons. thus larger atomic radius. Why is sodium larger than magnesium? Oh, okay. Sodium and magnesium are in the same period, right? From the periodic table, both sodium, are they in the same period, the same row? Sodium and magnesium are in the same period, but sodium has fewer protons right, has fewer protons, so it pulls electrons less strongly, making the atom larger. Yeah, so that's the reason why sodium is larger than magnesium. Then 30. Why is aluminum smaller than magnesium? Because aluminum has more protons, so the nucleus pulls electrons more strongly, thus shrinking the size of the atom. Then 31. Ionization energy. What is ionization energy? This one is a requirement to remove an electron. So ionization energy is the energy required to remove one electron from an atom in the gas phase. Have to delete that. Then 32. Why does ionization energy increase across a period? Because in ionization energy increases across period because the number of atoms, the number of protons increases. Then the ENC, effective nuclear charge, increases. Then electrons are held more tightly, so it takes more energy to remove one electron. Why does ionization energy decrease down a group? Ionization energy decreases down a group because atoms get larger, valence electrons are farther from the nucleus, then there is more shielding. So the electrons are easier to remove. Then number 34. Why is there a huge jump in ionization energy after removing all valence electrons? So there is, okay, after removing all valence electrons, because the next electron removed would be a core electron, which is much closer to the nucleus and held very tightly. So removing core electrons takes a lot of energy. And then for 35, why is it 35? Why is it easier to remove a valence electron than a core electron? I just mentioned it. Because valence electrons are farther from the nucleus. And they also experience more shielding and are held less tightly. Then for 36, why is the third ionization energy of magnesium so high? Magnesium has 2 valence electrons. Magnesium is in group 2, right? Has 2 valence electrons. After removing 2 electrons, the next electron is a core electron. It only has 2 electrons. So core electrons require much more energy to remove. That's why it has like very high ionization energy. And then for 37, what does a large jump between ionization energies tell you? So a large jump, here, 37, a large jump tells us that all valence electrons have been removed. And the next electron is a core electron. So this helps identify how many valence electrons the atom has. Then we have 38. What is shielding? So shielding, I hope we can finish this, is when inner electrons block the attraction between the nucleus and the valence electrons. And then for 39, why does shielding increase going down the periodic table? Shielding increase going down the periodic table because more energy levels or shells are added, meaning more inner electrons that block nuclear pool. So I'm worried because I have another student next and I will lose my voice. Okay, 42 more questions. How does adding protons change effective nuclear charge? So adding protons increases ENC because the nucleus pulls on the electrons move strongly. Okay. Then 41. How does increasing ENC affect atomic radius? Increasing ENC means stronger pull on electrons, and the atom becomes smaller. Oh my, we really answered everything. Is it 41? Stella? Hello?